Let's now move to logical and virtual, Let's now move to logical or virtual addresses versus physical addresses. So let's say we write a program and we have this instruction a equal b plus 2. We know that when we run this instruction inside a process, we will have some memory allocated, and at a specific address we will have the variable a, and another one we will have variable b, and then we're going to read b, sum 2, and store that in the address of variable a. Now, the question here would be, if the program has not been loaded yet into memory, so it's just stored in a disk, but it's the compiled program, so like the C program that runs this, how does this program knows how are we storing the addresses of A and B, given that we don't know yet where they will be placed in memory if we first don't actually start the process, right? So how does the operating system support the definition of variables and memory if we don't know exactly where the process will be placed in memory until we actually start running it? And given that if we run the same process n times, we can have n different locations at which we are maintaining the process in memory. Well, the operating system helps processes and programmers differentiating between logical or virtual addresses and the physical addresses, the real ones that you have in the memory. Each process believes that its own memory starts at address 0 and goes up to a certain address. Okay, so all addresses are relative to address 0, which is the beginning of the process. This is the logical address. The physical one, of course, will actually start at a specific address and extend up to another address. For now, I'm just assuming that you take a big chunk of main memory and you place there the entire process. So it's contiguous, a contiguous set of addresses. We will see that this is actually not what is really happening, but let's keep things simple for now. So what the operating system does is that whenever a process tries to access something that is in memory, it uses a logical address and it says, I want the address 346, for example. And then the operating system will translate that actually to the physical address in the real physical main memory at which the variable is maintained. The question is, how do you convert logical to physical addresses efficiently, getting help from the hardware? Something you can do, very simple. We will see again, as I said, that there are more complicated things happening, but for the discussion so far, something simple you can do is to use a relocation register. So basically, you take the address given by the CPU, and since the process believes its first address is 0, it basically means that it's giving you an offset. You sum to that the base address of each process, and that it's basically the conversion to the physical address you actually need to access in the main memory. So logical addresses will go from 0 to max. In practice, the real one will go from a certain R to a certain R plus max.